Hey, welcome everybody. Really nice to be at the EVerest Energy Summit. Welcome to my EVerest talk, giving you an update on what EVerest is, where we are, and how we think it can stabilize the grid. So, my name is Leeuw. I joined PIONIX last year, January. Also now have the honor to be an ambassador for the Linux Foundation Energy, and since last week the chair of the EVerest Energy Special Interest Group for EV Charging. So diving deeper into the open source world as we speak. What is EVerest? Anybody that doesn't know EVerest? No? Then we go quickly over what is EVerest first. It's an open source charging station software stack. So if you want to make a charging station, you need software to do that. That's what EVerest is aiming to do. Why EVerest? Is it that hard to charge a vehicle? Seems to be. There's some reports, and these are just two of them. There's a lot. University in San Francisco sent a bunch of students around, try and charge on a DC charger. They ended up with a success rate. So what is it? 72%? That means 1 in every 4 sessions fails. That is not good. I heard a podcast, CEO of a charging station operator saying, our goal is to have an uptime of 95%. 95% on 356 days means the charger can be offline for a week or 2. They think that's fine. That's not good enough. Monta did a survey, big charge point operator. 74% of the people they interviewed, and this is 1,700 people they interviewed, had a problem charging. That's 3/4 of the people trying to charge having problems. That is not good enough. Why is it so hard? Okay, it's a little bit more than just plugging a plug into a wall socket and get power. There's a lot of protocols involved. It's a charge point operator that manages charging stations. They need to talk to the charging station. Now there's a protocol for that, that's called OSPP. You need to talk to the car. And that's IEC 61851, ISO 15118, DIN spec, CHAdeMO, GBT, US, and J3400. So a lot of different standards that need to be implemented. Now, if you want to feed energy into the car, but you want to have a bit of control, you might want some local energy management. There's a couple of options. The most logical ones at the moment seem to be Matter, Germany, typically EEBus, but there's way more of those. You want to integrate a payment terminal in a charger? There isn't even a standard. Every payment terminal has its own interface. That means any integration you do with a payment terminal is an additional integration, additional work, additional things that can go wrong. Any implementation of software means somebody will read the spec, implement it, make small variants in how they do that. This causes in EV charging at the moment, there's just way too many variants. There are too many different EVs for too many different charging stations with too many different backends. It is impossible to test. When I started in EV charging 11 years ago, oh, there's a new EV coming out in 3 months. Let's try to get our hands on the new Tesla Model 3. That was doable. Now it is, there's a new EV coming out next week. Let's try to get our hands on an Opel Mokka E. Next year is probably there's a new car coming out next day. You can't test that. Other way around, there's so many charger manufacturers, at least 250 or 400 of them. If you're an OEM, you're making vehicles, you can't test with all of them. You can't keep up. Now, by taking all these variants out of the equation, have one software stack, EVerest running all of these, things become testable again. As an OEM, you can test against 1, 2, maybe 3 different EVerest charging stations. It's the same state machine, the same software, the same protocol implementation. You know it will work. On the other side, the backends, the charge point operators that need to work with this, home energy management systems, apps, you can start testing again. And this really solves the interoperability issues that we see in the field. We can go even one step further. If you go open source, we have another project within Linux Foundation Energy, C3NOS. Imagine having one backend to manage all these charging stations, just running the same open source engine. Now that becomes easy to test. Eclipse, software-defined vehicle, or somebody else doing the charging station side, the charging controller inside the vehicle. Things become way easier if everybody's running the same software stack. Things become testable. We save a lot of time, effort developing and testing all of this. So what is EVerest? It's a software stack for charging stations. So hardware, yeah, that's something that the charging station manufacturer still needs to do. Display, user interface, that's what's unique for their charger. They're not, this is what sells their charger. They think they make money by implementing all these different protocols. That's just commodity. You're not implementing TCP/IP anymore. That's commodity, you shouldn't do that. And we're making all these protocols commodity. So EVerest is the stack, the protocols, all the state machines to run a charging station. Now what you can do with that, you can make a very small home charger with it, you can make a very big charging site with energy management on top of it. You can run it as software. If you are making software that does something in the vehicle or on the CPO side, it's open source, you can even run it as a simulator. So a lot of options to use EVerest. So EVerest in a nutshell, we're here. It's a LF Energy project. It was initiated by PIONIX, the company I work for, in 2021. We do an Apache 2.0 license, so use it as you want. We would love to get feedback on input from the community, but you're not required to give back to the community. We do need embedded Linux to run, so if it's something bare metal, no operating system, then we are not able to run. It's a modular microservices architecture, so we run MQTT and a lot of separate modules. So it's very modular, you can easily add and reduce modules that you would need for your charging station. We implement all the relevant protocols. I will give you an update on where we are at the moment. It has a graphical interface to configure all these modules. So what you see here is an image of our graphical configuration tool, where you can just add additional modules, link them up, and this creates a configuration file that you can then load into your hardware. It does energy management. Main development language is C++17 at the moment. We are getting Rust support. It is possible to write Rust. There are some people also in this room writing Rust modules for EVerest. You could do Python and JavaScript, but as this is a production system used in the field, you don't really want to do scripting languages on production hardware. If you open the GitHub repository, you will see a lot of Python and JavaScript. That's all testing or configuration tools. So we've been working 3 years on EVerest now. So what's our current status? This is all our protocols on our roadmap. So everything that is light green is done. Everything that is black is work in progress. Depends. Maybe if you ask me end of the week, end of next week, this is done. Then we move over to the next one. Some people move OpenADR, EBus is work in progress. A Chinese standard for charging. There's a Chinese committee working on an open source stack for GPT. Talked to their leader Monday. They're expecting to be ready by October, and we will bring that into EVerest as well. And then there's a lot of stuff coming, and there's always more coming because the standardization committees are always working. There's new standards coming out. I think in a month or two we will be up to speed with the industry. EV charging has been developing for 15 years. We started 3 years ago. OCP 2.1 draft is out. This will be ready by the end of the year. We will also probably have implemented it by then. This one is also new, still in draft. We will implement it before the spec is out. So we will start leading the development of EV charging software where now everybody's still following. We have a huge growing community, a lot of standardization bodies, Joint Office of Energy and Transport is an interesting one to name. These guys are responsible for the NEVI funding in the US. So the Biden administration made a couple of billion available for charging infrastructure. The Joint Office is responsible for distributing the money to companies that want to install chargers, but it's also responsible to make sure that it's possible to comply with the regulations. So they selected EVerest as the reference platform, and they're also helping us implement EVerest. They have a couple of developers testing and developing code to make sure that EVerest works in the US. And that brings us visibility in the US even more. They're looking for pilot customers to use EVerest in pilot projects. So we see some chargers also in the US now starting to exist. Universities that we work with, charge station manufacturers implementing EVerest, more and more are starting to become public. We're still at the point where people are, yeah, we don't want to say. So we have a lot of people under NDA, they don't want to tell that they're using EVerest. My conviction is within 2 or 3 years we have this new charger and it is powered by EVerest because that's the thing everybody trusts. And we work with a lot of hardware manufacturers, a lot of development kits. More on that in the next slide. Also interesting, I think, for the other projects within Linux Foundation Energy, we started using Zulip. I think the typical chat tool within Linux Foundation Energy is Slack. The drawback of Slack is we have a free tool, free version, we lose messages. I know some other projects are using Discord at the moment. Zulip is an open source alternative to Slack. Bit of a learning curve compared to Slack, but I think we really love it at the moment. You see our uptake of active users. We are growing quickly. We started using it in January this year. Traffic is kind of constant at the moment. What I do love to see is the interaction between the different people in the community. A lot is happening on public, but there's also a lot of direct messaging. So really developers talking to each other, hey, I'm doing this pull request. Hey, can you fix something for me? Or I have this question, they know which expert to talk to. So really active community already at the moment. Would love to see more people, but already very happy with what we have at the moment. We try to keep a track of what is really out in the field. So who is making charging stations already running EVerest that you can already encounter in the field. One I really like to mention as well is Quello, one of the contributors to EVerest. They have existing infrastructure. They bought a company that had an existing infrastructure, more than 10 years old. They couldn't get it updated anymore. They're doing a retro kit. So they bought a development kit from one of the hardware suppliers and made a new cable harness, did all the certification and are now retrofitting the charger. Where a lot of companies are just taking them off the ground, scrapping them. These guys are reusing it, so also environmentally friendly on reusing hardware, which I really love. Yeah, so we really see starting really to see volumes. Some of these are customers also from PIONIX, getting professional support from us, starting to really install volumes in the market. Yeah, we need professional support. I don't think we got really a lot of questions, so really happy with how EVerest is working in the field, because we don't get that many complaints at the moment. Then we have some hardware manufacturers that are working with EVerest at the moment. All of these have development kits that are either upcoming or already available. In the end, they want to sell the hardware. They either had a contract with a commercial software supplier. In the end, their customers want a complete solution. Open source is the easiest way to go. The 5 Verso, for example, is the one that Quello is using for their retrofit kit. Now, we also do some stuff. We have a belay box. If you want to build a charging station software, you need hardware. You can't just take hardware off the field, put your own software in. Because if somebody did a really good job, that means that software is secured. You just can't install your own software. So we built our own software development kit, which is open hardware. You can even go online, GitHub, the PIONIX GitHub repository in this case, All the Gerber files, all the schema files, the layout files are available for download, and you can just build your own boards. Or you can buy them from us. We build them typically with 50 at a time. Might be cheaper than building your own boards, but if you really like to hack around, you can do it yourself. The last one is also interesting. We want our belay box as an AC charger. If you really want to charge fast, you do this to DC. DC is also the most complex one because it requires a lot more software and communication. For testing, we built a portable test device. We built this for ourselves. And then we went to a test event, and the first car manufacturer that we tested with said, "Can we buy one?" Like, "No, this is ours. We built this for ourselves." The second one said, "We want to buy one." Nope. Third one said, "We already called our guys from commercial vehicles. They also want 3. That's not the plan. We want to do software. We don't want to be a hardware company. Now we sat down and thought about this a bit. We started producing them. So we now sell our micro megawatt charger. It's a portable charger. I should have put a picture in. It's really nice and tiny, and all the OEMs want one. Why do we start selling them? That means all the OEMs in their labs, when they start testing the vehicles with these DC charging protocols, are using EVerest. So solving the interoperability issues, we don't need to test. The OEMs will test for us. So perfectly win-win for both. They have something to test with, which is easy to work with, which is affordable, and we get feedback if it works really well. And it saves us time on testing. So that was EVerest. So how do we think EVerest can help stabilize the grid? A lot of this should also not come as a surprise for people that are working in the energy industry, but there might be people that are new, so a bit of a recap. This is the typical energy consumption in New England in this case, during different periods of the year. So at night, there isn't that much energy consumption. It goes up during the day, and there's an evening peak. Everybody comes home, puts on the oven, the washing machine. That's our biggest peak. So, as Jonas from Alliander was saying, yeah, we designed the grid for 7 days a year. There's 7 days where this peak is really high. This is what the grid is designed for. For the rest, there is no problem at all. Now, if you would add EVs to this, when do people come home? 4 or 5 o'clock, the same time as they put in they turn on the oven or the stove, and you start charging your vehicles. So this would increase the peak and put a more strain on the grid. That doesn't need to be a problem. So the simplest solution is, instead of starting at 4 or 5, start charging 10, 11 o'clock. Everybody goes to sleep. The car has enough time to charge overnight. And this peak moves over here and is lower and still fits the grid. Or you can even do even better if you have cars that can give energy back to the grid. In the end, the car is a very big battery. If you look at the price of an EV, compare that to a home battery. If you buy an EV, you get a very cheap battery, including tires, a steering wheel, and a chair. It really is. I'm looking for a home battery at the moment. It's 15 kilowatts. Cost me 7,500 euros. Buy a car, you get you get the same amount of battery power, including wheels, chair, and all of that. If you would do bidirectional, so feeding energy back in the grid, that means during the night we start charging the vehicles. In the morning peak, vehicles could even give back to the grid, so the really grid usage drops. During daytime, there's enough energy. We typically see a lot of negative energy prices even in summer or during daytime. Charge the EVs at the office or at home if you're at home. And then in the evening peak, the vehicles can give back to the grid. This is the biggest peak. This is what we built the grid for, this peak. We can even drop it. That means additional copper, not in the last parts of the grid. Yeah, the central grid might need some work, but in the end, the grid can cope with it, if everything is working. That needs a bit of work. I stole this picture from Alex. He used it Monday on his presentation he gave for a lot of EV charging guys. It is complex to get done. So we have all the power systems, the grid, the distributors. We have mobility service providers, so these are the guys that have contracts with drivers. The charge point operators, they operate the charging stations, they're in control of what's happening with their infrastructure. They buy it, it's theirs. Then we have the charging station here in the middle, and it talks to the EV, and the EV might talk to the car manufacturer, the OEM, because they typically have a back-end connection, which is proprietary. And then you see all the different protocols, and this isn't even a complete picture. This is what we need to get done and working and stable and standardized to make V2G work. It's a lot. How do you test this? With 400 different chargers, a couple of thousand different EVs, a couple of hundred different CPOs. So then you're a transmission system and you want to control this and you want to have predictable behavior from everything that's behind this. Why did we do EVerest? It's an interoperability issue. There's way too many different systems. So what if we do the same for the grid? Just imagine this not being communication channels, but just a grid. So we're taking energy from the grid, putting it into the charging station, and then from the charging station into the EVs. Imagine having EVerest in the middle. That means that the grid guys get predictable behavior from the charging stations, and then it goes to the cars. Now, taking then the other picture as well, where this is also predictable, having the same open source software stacks everywhere might make this testable, but without, it won't be possible to really get predictable behavior. Even if you write really good protocols, there will be differences in the state machines. I already covered this one. Same algorithms, same state machines will really make a difference. So where are we with EVerest with V2G? We have some stuff to do. So the first picture I showed with delaying charging, smart charging works. To do bidirectional charging, we need 1511A-20 in Europe and in the US. That's a work in progress. We can charge. We don't have the bidirectional power transfer. So this is the acronyms here. DC bidirectional power transfer. That's on our roadmap to do. So that means on a DC charger you can do bidirectional power transfer, but at home the cheapest thing to have is an AC charger. Smaller cable, smaller box. But to be able to do that, you need AC bidirectional power transfer. That's still a draft specification. So as soon as we have implemented this, we also will do the draft specification. Already in talks with OEMs that want to test with us that do AC bidirectional power transfer with their first vehicles. OCPP 2.1 is needed to get this thing working. Now that is on the roadmap to start working on in probably 2 or 3 weeks when OCPP 2.0.1 is done. OpenADR, work in progress. Somebody's working on that. EVerest is work in progress for us. I'm trying to convince some people to do Matter. So OpenADR is a big standard basically in the US, but also in Europe more and more. EVerest, as I said, this is more for grid control. So this is control from the grid. EVerest is more in the home segment. So if you have a home energy management system talking to your home charger, typically in Germany we're working on that. Matter is a standard from, top of my head, Google, Apple, Facebook, to do home automation that also now with version 1.3 has a profile for EV charging. I'm trying to convince some people to do this for us. There seems to be an open stack, we just need the integration. So fingers crossed we get that also soon. And then on top of that we need to do energy management algorithms, something we're always working on. So work in progress. My hope by the end of the year we're done with most of this, maybe except the AC bidirectional one. So conclusion here, if you ever do something with EV charging, start using EVerest. Stop using proprietary solutions, especially if you are doing some research. If you're at the university, want to do something new, start using EVerest. You have full control, you can add everything you want. If you want to do some testing or simulation with something with EV charging, also there use EVerest-based charge, because that's what you probably will see in 2 or 3 years in the grid anyhow. And if you're building a charging station, for sure talk to us. Don't write your own software anymore. Don't write commodity things like protocols. Now, if you would ever need hardware, also reach out. For development, our relay box is available. And we also know manufacturers that make charging stations, so we can bring you in touch with people that really make the charging stations. One call for action: if you are in the EV charging industry, if you are interested in EV charging, LF Energy has set up the new EV charging special interest group, just kicked off last week. We will have a call in 3 weeks ago again. We also have a face-to-face tomorrow. So we're here tomorrow, demo station 1 at 3:30. Join us. We're trying to get as many of the open source projects that we know of in the EV charging space to join us. Use the QR code, sign up for the mailing list, and let's keep in touch. Do we have questions?
Thanks for the talk, Robert. It was very nice. I was wondering, on the big schema that you showed, there was also IEEE 2030 mentioned a couple of times. What exactly is the relevance of that standard for the EVerest project?
And so I'm not an expert on the IEEE standard for smart charging, for grid. What's the official term for that one? I think that is also a grid distributor or smart thing to share if energy is available or not. I think that is also a cloud-to-cloud one. So I don't think that will end up in EVerest. It's the same a bit with OpenADR. OpenADR 2.0 is really cloud-to-cloud, where the new 3.0 has a profile to also be on the charging station itself. So now it becomes also interesting for EVerest. Do you know the IEEE?
I heard a lot of interest, so people wondering if they should do it. So in a way it was missing on your list because
yeah, but I couldn't put them all in. My slide was only this big.
Yeah, I know. I'm involved in some this development. 2030.5, it's a standard for management of distributed energy resources, is something that should facilitate the communication between grid operators and distributed assets. And in that sense, is supposed to be better than going with 61950 in that respect, because it's lighter protocols, better for small units. And has been selected in California as the key element to make flexibility services. So it could end up in EVerest. I was just discussing yesterday evening with Marco. We are in a European project developing an open source version of 2030.5, and we'll make it available, of course, and very likely bring it to LFE. And so that's a synergy we can build within LFE in the close future, I guess. Yeah, yeah, that's what I heard. Because the California regulator identified 2030.5, make this and then, you know, oh, the Americans are going this direction, everybody's going this direction, it's kind of effect.
Thank you.
Yeah, you said your stack is running on a Raspberry Pi. Is it also possible to run it on an ESP32 or something like that? Or will it be possible?
I'm not a hardware expert, but I think the ESP32 is a bit too small.
So in principle, EVerest has a module system, and the big modules also have dedicated libraries. For example, for OCPP, we have a library. For ISO 15818, there's currently a library under development. And a lot of those libraries run already and are already used by some people on, let's say, small MCUs. So you can't, out of the box, reuse everything right now, but a lot of things are already there. And in principle, we're wondering, let's say, in a couple of years, if we port it down to, let's say, Zephyr or something like that, so to run on small microcontrollers. But at the moment, there's so much dynamics in all of those protocols, so much changes, and you would really love to have a proper Linux underneath to get all the encryption properly done. And at the moment, you can never make up the NRE by saving then $2 on a silicon.
Thank you.
Thank you for your talk. How did you develop your community to make it a success? And one other question: what is the market share of EVerest in charging station?
So community building, I'm looking at Marco again because I joined in January last year, and you guys were already building a community, so you might know better.
I got asked this question a lot, and so one part of the answer is I don't know. The other part of the answer is we just talk to everyone. We have been really, really insistent on pulling everyone in. You saw, for example, analog devices on the slide. Yeah, here we have them. So, and like really, yeah, investing a lot. I think we so far invested from our company like 7 million up to date so to grow EVerest. And yes, we also have a bit of customers, but most of the money is actually going into growing this community. So it was time and money and being really, really insistent and proactive.
And then you have a little bit of luck, I think, also. But I think one of the first big contributors was a hardware company. They had their own software stack, but they just wanted to sell controller in this case. So for them, the software just wasn't enabled to sell what they really wanted to sell. For them, was an easy step to go open source. And that makes it easy to get somebody then into the community. But in the end, it is talking and presenting everywhere, so you meet the right people that then might really start contributing. But that's, I think, the hardest part probably, which I hear from everybody.
And then the second part of the question, the market share, super hard to estimate. Just in general, this EV charging market is so crowded. We really try to find for our commercial efforts, like who has what market share from the hardware vendors. No one knows. It's really hard to get down to that data, and we really tried. I can just say our current commercial guesstimates from PIONIX is that we were ending up by 2026 with at least 500,000 charging stations running EVerest. That's already quite a lot. And but I know there's more. So things I can talk about, for example, Leeuw, which is a big French automotive company, they're playing with EVerest. I think there's at least 3 Indian startups already launched products with EVerest. So also in the open source community, that's happening quite a bit, and we can guess what's happening there. But since this is now reference design on basically all big silicon makers, over time it will end up everywhere. It's a long game.
But indeed, it's hard to guess because you don't know who's using it.
Hi, yeah, thanks for your talk. I think you started the talk with that the reliability of the average charging station was not very good, that only 75% succeeded and that also 75% of people experience issues. How is the EVerest stack performing on those metrics? And I maybe had also a follow-up question. You also showed a lot of charts where you can see a lot of complexity in the whole ecosystem. Are there any efforts being made to reduce that complexity, and how do you see the future? Like, it's probably also the phase that we're in, right? It's all relatively new technology, and people come up with different ways to do the same thing. But I can imagine in the end you want to have a bit more convergence, probably, to make your life easier as well. So.
I wish we could get rid of some of the standards so we don't need to implement all of them. So how is EVerest doing in the field? As I said, we have one customer really producing quite a high volume since May. How many support calls did we get? 1? 2? Did we even get one?
Basically feature request,
yeah. So and we were prepared because this is like the first real mass production for us with a commercial support from us. So we need to be ready because now they go into the field. So is everybody ready this week? Do people have some pace in their agenda? And then nothing happened. So we're like, okay. And we talked to them. They're really installing them. They're really in the field charging. So we hadn't have any. So we have a feeling it's okay. It's really good. But
if there's like a field charging session, how do you know the testicles?
Yeah. We do tests. So what I ideally want to have from our customers is see the sessions. But the problem with charging stations typically is that somebody sells a charging station, and that charging station then connects to the CPO. And that CPO isn't our customer. So the charger manufacturers typically also don't see that. Now we are developing a commercial solution for people that want support where they also have a second connection and have some statistics within a cloud solution. Then we get more visibility. But that is in development still. First pilots October, November. And then we will see the real world data for the first time from chargers, but that will only be people with a commercial contract. That is also, it's an open source project. It will only be a small portion or maybe half of the portion of all the EVerest chargers. So at the moment we don't see it. It would be nice to ask our customer if they have some statistics.
I think what's really interesting in this industry is that there are testables. So this complexity problem, what you see there now, is currently solved with something like tech speed dating events. So you have 20 cars, 20 charging stations, every combination is tested for an hour or so. And then you rotate to the next combination. And the same also happens with clouds, so CPO backends versus charging stations. That's another organization organizing those speed dating testable events. And there we typically score really, really well. And we now have a list of 60 cars, 50 backends we tested, and this is ever growing. And because now the goal is, what Robert showed, is kind of creating a monopoly, so everyone tests against EVerest. I mean, it's a friendly monopoly, obviously, but now this already creates gravity, and as more gravity we have, as more we attract, and then we're creating more gravity, and we really, really see that we're on that path. Also with the cars, with this micro-megawatt charger Robert mentioned. Meanwhile, now the car vendors starting to test themselves because they see like, oh yeah, you're an aggregator for, I have to do Teslas, and let's go there.
Thanks.
Thanks for the talk. So you were showing slide regarding the peak shifting at the household level, which is pretty interesting. But there are also some use cases at the distribution grid level wherein they say, okay, there is a particular node or a particular substation, and it would make sense at a particular time that the mobile vehicle-to-grid technology could work at that station, so that there is a possibility that the charge could like the vehicle-to-grid could happen at this particular node, which would help in congestion. So is there any such possibility to optimize at the distribution level, like select some nodes and give some signals through app maybe using EVerest?
Yeah, so that's not directly EVerest itself. Let me go back a slide. The complex one. This typically is OCPP, and OCPP allows smart charging where you can basically instruct a charging station what to do. The charge point operator should know where that charging station is. So normally the charge point operator is also the one to tell, on these grid connections, could you please reduce the load or put them even in discharging mode. But that needs to come in somehow, probably directly or this route to the CPO, because the CPO needs to get that from the energy company or the grid operator.
But meanwhile, you also see the direct route.
Yeah, and that's then also what Mr. Monti was talking about. If you get IEEE directly into the charger, different routes, then you might also do that. With a home charger, you might not, but the industry is also working on megawatt charging system, which means trucks that can charge up to 3.4 megawatts. For sure, you as a grid operator want to be able to control those. If you connect these to the grid and you have 10 of these on one side, I've heard Mylans is a company that is setting up these truck charging sites, and to get enough power, they're requesting the grid operators to provide overhead power lines, high voltage directly to the site, because these guys need tens of megawatts on site. You want the direct control for that. We had more questions.
Yes, thank you for the presentation. One question is, does EVerest support charging stations with independent storage and solar arrays, and do you connect to those assets as well?
Yeah, so our energy management has a lot of options to add inputs. And that energy manager is basically a credit-based system. You put in an amount of credits on energy and you draw out an amount of credits. And it's just a matter of feeding in protocols. And then it really depends on which protocols have we implemented in EVerest, if we can control those.
So just to clarify, is that when you say credits, that's against the grid then? But for, let's say the charging, the actual charger had a energy storage on site, does it communicate as well?
And when I talk credits, our algorithm to do energy management has some credit-based algorithm to internally to calculate how much is coming in, how valuable is this, how much am I feeding out. We do have Modbus, and a lot of battery storage systems have used Modbus, so we can easily use Modbus to talk to a battery storage system. Same is for inverters for solar. It's all a matter of just linking them up, feeding them into the energy management system, and then we can work with these complex sites where everything is included. Any more questions? Thanks for your attention, and thanks for the great questions as well.